Okay, today we are looking at classifying functions, equations, tables, and graphs as exponential growth and exponential decay. Now, some of this is going to be review for you. I think some of you have kind of already put these ideas together, and we've talked about them, but we're going to have a video that puts everything together in one and then an assignment that follows that. So the question that we're looking at today is, how do we know if an equation, a graph, or a table represents exponential growth or exponential decay? Now, for an equation, remember our equations are in this form. Now, if it's not in that form, it's not exponential growth or decay. It has to be this form. And what we look at is that b value. If that b value is greater than 1, then it's growth. If that b value is between 0 and 1, it's decay. And that's the only thing we need to look at. We just need to look at that b value. Okay? If it's something other than that, like a negative number, it's neither growth nor decay. And I'm not going to give you any problems like that. Ours, you're just going to have to make the distinction, well, is that b value bigger than 1? Or is that b value between 0 and 1? On a graph, we want to look at the shape of that it's making. If it starts out small and then rapidly grows and goes up, that is growth. If it starts out really big and then gets smaller, that is decay, because that's what the names implies. Growth implies that it's going to get bigger, and we read graphs from left to right. We read them this direction, so it should be getting bigger on the right hand side. Decay, same thing. Decay implies that it's getting smaller. We read it from left to right, so it should be getting smaller as we go from left to right. Okay, so really here we're just looking at that shape, and you should be able to make that distinction fairly quickly. The last one, in a table, we're going to look at the pattern, and this is really what we've been looking at the last couple days. Okay, if we are multiplying in that pattern, then it is growth. If we are dividing in that pattern, then it's decay. If it's something else, like we've already looked at adding and subtracting, those are linear, so those would be neither growth nor decay. And on tables, I'm going to ask you that, since we've talked about other patterns. It's not just going to be growth or decay, it's going to have neither in there also, so you need to be looking for adding and subtracting as well. But if it's not multiplying, it's not dividing, that would classify it as neither. Now we have examples of all three types here. Okay, we're going to start out with what I think is the easiest one, the graphs. Okay, remember, for the graphs, we are looking at the shape. Okay, well, our first example here, we're looking at it from left to right, and I notice that it is going up. Okay, it's getting bigger. That tells us that it's growth. Okay, and that's all we have to look at. For the second example here, again, we look at it from left to right, and we see that it's getting smaller. Well, that tells us that it's decay. And it's that easy for the graphs. You're really just looking at that shape. The next one we're going to go to are the equations. And for the equations, remember, we're looking at that b value. Is it bigger than 1, or is it between 0 and 1? If it's bigger than 1, it's growth. Between 0 and 1, it's decay. So we have 6 examples here. First example, that b value is a 5, and 5 is bigger than 1, so this one is growth. Okay. Next example, again, we're just looking at this b value, the part that has the exponent on it. Here, our b value is 1.9. Well, that is greater than 1, so it again is growth. The last one over here, this is the trickiest one. Okay, the ones with fractions there, because some people just assume, well, if it's a fraction, it's automatically between 0 and 1, and that's not the case. You want to look at the type of fraction you have. We have an improper fraction here. We've talked about this in class before. Improper, or what some people call a fat head. Okay, fat head means that the top part, the numerator, is bigger than the denominator. Okay, if that's the case, that means that this is bigger than 1. You could also use a calculator and put in your calculator 6 divided by 5 or 6 over 5, and you get 1.2. 1.2 is bigger than 1, so it's growth. Okay? Like I said, those fraction ones are going to be the ones that confuse you, that are going to make you think. You really have to think about, well, is it an improper fraction or is it just a regular old fraction where the numerator is smaller than the denominator? Okay? Let's carry that idea on into the next example. We have another fraction here. Okay? This time it's 1/3. Well, 1/3 is just a regular old fraction. The numerator is smaller than the denominator. That tells me that this is going to be less than 1, and since it's positive, it's bigger than 0. Really, if I put that in a calculator, I get 0.3 repeating, which is between 0 and 1. So this is decay. All right. Next example. Again, we're just looking at that b value, and here it's 0.1. 0.1 is between 0 and 1, so this is another decay. The last one here, we're looking at that 8/11. Okay, 8/11. Well, the numerator is smaller than the denominator. That tells me it's a regular old fraction, so it's going to be between 0 and 1 and be decay. All right. On these, I don't think these are too hard. I don't think you guys are going to struggle that much, except for the ones that are fractions. Just be sure that you look at the b value. The a has nothing to do with it on these. The ones that are the hardest are these last set, these tables, because in the tables, remember, we could have neither as an option. Sorry about that. Let's go back into our presentation. Here we go. We could have neither as an option here. Neither meaning that we are adding or subtracting. Okay? Growth, again, means we're multiplying. Decay means we're dividing. That's what we're looking at. So we're looking at our y column here. Okay? And we want to figure out what we're doing in that y column. So how did we get from 5 to 9? How did we get from 9 to 13? Well, here we're adding 4. Okay? That tells us that this table is neither growth nor decay. All right, let's look at the next one. How did we get from 3 to 12? And from 12 to 48? From 48 to 192? Well, here we are multiplying by 4. And since we are multiplying, that tells us that it's growth. Okay? Now on the next one here, I can see that I'm getting smaller, and that's an important thing to notice. But I want to make sure that I'm dividing and not subtracting. Okay, if I'm dividing, it'll be decay. If I'm subtracting, it's going to be neither. Well, how did we get from 70 to 68? 68 to 56? You might want to use guess and check here. Okay, it's getting smaller, so try some division, try some subtraction, and see if you can figure it out. I know that this is going to be subtracting 12 each time. I know that for 2 reasons. I can see it, number 1. Number 2, I made up the question. So you guys might use guess and check here, and that's perfectly fine. But since we're subtracting, this is neither. Okay? Last one, it's also getting smaller. That's a clue that it could be decay. We want to figure out, well, how did we get from 81 to 27, 27 to 9, 9 to 3? Well, we're dividing by 3 here. Now, really, today I'm not concerned with you making that b value into a fraction. That's going to help you understand it, because b is between 0 and 1. It's 1/3 here, which solidifies or further proves that this is decay. But the fact that we are dividing is all that we need to look at in order to make it decay today. Okay? So those are our examples. We have 3 types again. Graphs, which I think are the easiest. You're going to be able to look and say what they are. The next one, the equations, still not too hard. You're just looking at the b value. Make sure you look at the b. The ones that are going to be the hardest are these tables, because I am going to throw in that neither option for you. If you have questions, please post them to the discussion board. Otherwise, good luck on your Schoology assignment.